All right, everybody, welcome back to Research Methods. Today we are talking about experiments. But before we can talk about experiments, we have to talk just a little bit about the word causation. When we say one thing causes another, what exactly do we mean? Now, in normal conversation, if we say this caused that, we're talking about causation as an idiographic thing, right? And an idiographic idea of causation is that there's some sequence of events. A caused B, B caused C, C caused D. I cheated on my wife, and that caused me to get a divorce, right? Scientists much more often deal with nomothetic causation, which is where variation in one variable causes variation in another. We increase police presence in a city, and thus crime goes down. Or we introduce a new law designed to reduce domestic violence, and thus domestic violence goes down. You know, that kind of thing. The problem with this idea of causality is that it can be difficult to find what's called a counterfactual. And a counterfactual is just a really fancy word for what would have happened otherwise. So if we pass a new law and then crime goes down, does that mean the new law caused crime to go down? Or would it have gone down anyway? We elect a new president and the economy gets really good. Was it the new president that caused the economy to get really good? Or would it have gotten better anyway? Right? We don't have, in those situations, a counterfactual. We have no evidence, we have no data to give us much of a clue what would have happened without that thing that we think is the cause here, but, might not be. Now, as a scientist, if we want to establish that one thing causes another, we need 4 things. Some textbooks say 3, some textbooks say 4. I'm of the school of, I believe there's 4 requirements to causation. And we're going to talk more about that in a minute. But the best way to establish causation is with a true experiment. Okay? A true experiment has 4 requirements. Number 1, at least 2 groups. If there's only 2, we usually call them experimental group and a control group. Okay? There can be more than 2, but there has to be at least 2. Number 2, there has to be some kind of treatment or intervention. Could be a new drug, could be a new law, could be an increase or decrease in police presence, whatever. Number 3, there needs to be an observation, right? and if the observation is made prior to the treatment, it's called a pretest. An observation is made after a treatment, it's called a post-test. So we need at least one of those, but we can have many, again. And then 4, you need random assignment, which many students often get confused with random selection, but random selection is about sampling. Now we're talking about actually gathering our data, dividing people into groups, and since we have at least 2 groups, to be a true experiment, we have to randomly assign them to one of those 2 or more groups, right? You can flip a coin, you can draw lots, you can use a computer, whatever, but all of the members of your sample have to be assigned to the group randomly to try to make sure that those 2 groups are as equivalent as possible prior to actually running your experiment. So those 4 things are our requirement for those 2, for that true experimental approach, right? This textbook that I'm taking this slide from there, they only say the 3, but the way I learned it was 4. Okay, so the way that this textbook discusses causation, it says you need at least 2 groups, you need that random assignment, you need that treatment, or as they put it, manipulation of an independent variable, but you also need a measurement, you need an observation, right? And they kind of assume that, but I like to explicitly spell it out, all right? Now, These are kind of the gold standard in science. These are the cream of the crop. If we can do a true experiment for everything, research would be a heck of a lot better. The problem is it's not always possible. And even if it's possible, it's not always easy, especially with, costs and time and all those other things. So a lot of times we can't do a true experiment, again, either because it's physically impossible or legally impossible or just really expensive and time consuming. So there are alternatives to true experiments that are in many cases almost as good. But we'll talk more about those here in a bit. Now, there are lots of different kind of ways to design a true experiment, and each one has kind of positives and negatives. The simplest one is the two-group post-test only design, right? We get our two groups, an experimental group and a control group. We randomly assign all of our sample to one of those two groups. Again, you flip a coin, draw lots, whatever. Then we give the experimental group some treatment that we don't give to the control group. And then we observe whatever the dependent variable is afterward, right? So we divide people up into two groups randomly. The experimental group gets a education program, and then we observe how much they recidivate afterward, right? Now, in experimental notation, this is what we did. We've got the 1 and the 2, right? So that's our two groups, and the R there stands for random assignment, so we've randomly assigned them to these two groups. The X in the first group indicates the treatment, and the O's are observations or measurements, right? We've randomly assigned everybody to two groups, did our intervention to the experimental group, and then measured both groups afterwards. And this has all four of the requirements for a true experiment, right? At least two groups, check. Random assignment, check. At least one intervention, check. And at least one observation, check, right? So this is as simple as a true experiment can get. But there are some problems here, some lacking features that we might want to improve upon, right? So another way we can do a true experiment, a little more complicated, but giving us, in many cases, a little bit better data, is the two-group pre-test, post-test design, okay? So this is going to be the exact same as the previous example, but in this case, we're going to incorporate a pre-test as well. So we're going to observe our dependent variable before the treatment, and then again after the treatment. So we're actually going to be doing our measure twice, okay? And in experimental notation, it looks like this. We've got our two groups, we've got random assignment, we've got observation, then the treatment for the experimental group and no treatment for the control group, and then another observation, right? So maybe we're trying a new weight loss drug. So we get 100 people, divide them into two groups of 50, and then we weigh them. We put them all on a scale. We mark down their weights. Then we give the experimental group this new drug. We get the control group a placebo. And then after 6 months or whatever, we put them all on a scale again. And that way, not only can we track what happened after the treatment, but we can really track how much of a change it had. Right? So maybe the control group also lost weight just because of the placebo effect, right? Now, with this design, we would know that. Whereas with the post-test only design, we would have never known, right? Now, one of the problems with that design is that that initial observation can have an effect on people's behavior. So maybe the people in the control group in the previous example, it was a weight loss study, maybe just the act of weighing them makes them think, oh my God, I really need to get in shape more. So it causes them to go out and start exercising more, etc., etc. Maybe instead of a weight loss experiment, it's a cognitive, like a test, right? Like an actual test, like you would take as a student in class. And the mere act of taking the test helps you learn about the test so that you'll score better on it the second time, even if you haven't learned any more about it in a formal setting, right? Just the mere fact that you're taking the same exact test for a second time means you're probably going to do better, right? So this is another common one, or a very powerful research design called the Solomon 4 research design. And in this case, instead of our 2 groups, we're going to have 4 groups, right? We're still going to have random assignment to the 4 groups. There's going to be 2 experimental groups and 2 control groups. One of the experimental groups and one of the control groups is getting a pretest. One of the experimental groups and one of the control groups is not, right? So this is what it looks like. 4 groups, randomly assigned. An experimental group and a control group get an initial observation. An experimental group and a control group don't. Then both experimental groups get the intervention or the treatment. And then all 4 groups are observed at the end. This way, we get all the benefits of the pre-test, post-test design, like we talked about before, but we can also help control for and measure and see if we can find any of those testing effects that initial observation may have incurred, may have brought about, right? So this research design, even though it's fairly complicated, helps to really, really, really isolate the effects of just that independent variable. Only the treatment effects can be as accurately measured using this kind of system as it can in pretty much any system. But unfortunately, that's not always possible, right? There might be some physical reason or legal reason or something where we can't have that random assignment. We can't have 2 groups. It can be very difficult to kind of perform that kind of experiment based on money, based on time, based on legality, based on the nature of the physical universe. And we're going to talk more about that in the next subsection. Thank you for watching.